So for 9E, we're going to have a look at the chain rule. So this rule is needed when we have brackets with large powers. So if you had something like x cubed plus 1 squared, up till now you would have gone, oh, well, I need to expand. So x cubed times x cubed, x to the 6 plus 2x cubed plus 1. And then you'd find the derivative of that. And that's okay. But what if it was x cubed plus 1 to the power of 10? To expand that out would take a really long time. So what we're going to do is use this chain rule to find a technique for differentiating expressions like this. And the chain rule says dy dx equals dy du times by du dx. So you sort of think of it as, it's like fractions in Year 7 where the u's cancel out like that. So then you'd be left on this side with dy dx. So what we do is we look in here and we say, what we're going to do is let u be the inside bit, x cubed plus 1, this bit. So then y, I'll put a y there, y is whatever this expression is, u to the power of 10, because x cubed plus 1 is u. So when you go to differentiate it, you follow this rule. Dy dx equals dy du. So dy du is 10u to the 9. Du dx is 3x squared. So then by this rule, the derivative of this function is dy du, 10u to the 9, times by du dx, which is 3x squared. And u is x cubed plus 1. Or you could write that as 30x squared x cubed plus 1. And if you pop this into your calculator and get the derivative, that's what it gives you. So this is the chain rule. And it's really important that you can do this well, because we'll use the chain rule in our next few rules. And if you can't do this quickly, then you end up in all sorts of trouble. So let's have a look at an example. I'm going to say that y equals 4x squared plus 3 to the 5. 4x squared plus 3 to the power of 5. So we let u equal the inside bit, which is 4x squared plus 3. Y equals whatever this is to the power of 5. So du dx is 8x. Dy du is 5u to the 4. So that means dy dx, which is dy du, this, times by du dx. So 5 times 8, 40x. And instead of writing u, I'll write my whole expression, 4x squared. Why do I keep doing that? Plus 3. Let's do another one this way, and then I'm going to show you a shortcut. So if we had 2x plus 1 to the minus 2, and that's what y is equal to. So u will be 2x plus 1, so du dx is 2. Y is u to the minus 2, so dy du is minus 2u to the minus 3. So when I do du dx times dy du, I'm going to get 2 times minus 2 is minus 4, and then u to the minus 3. I'm just going to have a look that that fitted all on the page. Perfect. It's a bit of a change, isn't it? All right, so now I'm going to teach you a shortcut, because if we look at this, what's happened is the 5 from here goes out the front, and then it's, hang on, I forgot to put the 4 here. Sorry, peeps. The 5 goes out the front, and then it's this expression, the power of 4, and then you times by the derivative of the inside. So if you remember the meme with the mother and the baby, differentiate the outside, differentiate the inside. I'm going to send that to you. Let's have a look at a third example. This time we'll try and do it a quick way. So we're going to say that y is 3 minus 2x to the minus 4. And I'm going to try and make this a bit clearer. So what we do is we put the minus 4 out the front first, keep this the same. So I call that differentiating the outside. And now I multiply that by the differentiating the inside. So the different derivative of this is minus 2. So my answer is 8, 3 minus 2x to the minus 5. Differentiate the outside and then differentiate the inside. What about if we have this one? It's a bit hard, isn't it? It's got letters instead of numbers. Doesn't make any difference though, does it? So if I want to find the derivative of this, I find the derivative of the outside. And then I multiply that by the derivative of the inside. And that's really the way you have to learn how to do it as we move forward, because you're going to end up doing the chain rule within another rule, so you need to get good at it. So we could just write this as minus 2, 3ax squared plus b over ax cubed plus bx cubed, because I'll put that down the bottom. All right, so let's have a look at one from the textbook. So if you go to 9E question 3, this is page 378. It gives a function y equals 16 over 3x cubed plus x. And it wants you to find the gradient at 1, 4. So what we're going to do first of all is find dy dx. So I'm going to rewrite y like this. And then I can do a chain rule and everything will be fine because I can sub in the 1. So dy dx equals, so let's differentiate the outside. This is going to be minus 16, 3x cubed plus x to the minus 2. Multiply that by the derivative of the inside, which is 9x squared plus 1. So this could be more neatly written as but on your exams it won't matter. If you left it in that form, they'll be happy. The second part of the equation says find the gradient at 1, 4. So when x equals 1, the gradient dy dx is minus 16 times 10 over 16, which is just minus 10. So I'll leave you to do 9E, and we really need to get that sorted out before we head on to some of our later exercises.